Hey guys, today I'm going to be doing a video showing every single button in the cockpit of the Citation 501. If you watch this video, I think you'll really enjoy the full flight videos because you'll know exactly what all the buttons do in the cockpit. So let's begin. So we'll start off by looking at the co-pilot side, and here's the headset for the co-pilot, and here's the oxygen mask. Here we have some circuit breakers. They're kind of related to the RVSM and the ground proximity warning. Here we have the actual oxygen mask, and when we're not flying the plane, we always leave it unplugged because there's always tiny little leaks. But when we do plug it in, what's going to happen is it's going to sense the pressure, and this tab is going to turn green. This here is the microphone for the oxygen masks. So that brings us to this switch right here, which is when it's moved forward, it's going to use the microphone out of the normal headset. But when we flip it to the back, now it's going to use this plug right here, which will use the microphone out of the oxygen mask. And here are the right hand panel circuit breakers. Now let's take a look at the yoke for the co-pilot. The red button here on the right is the autopilot disconnect. We also have the autopilot temporary disconnect. So we hold this down and temporarily disconnect the autopilot, and when we release it, everything comes back on the way it was. And then up here on the left side, we have the ident switch. So it's very convenient because you don't have to reach down to the transponders. Also, last but not least, on the yoke is your push to talk button. On the Citation, at least this vintage, it's not push to talk, it's slide to talk. Moving along to the upper right side of the co-pilot instrument panel, here we have an analog clock and the Hobbs meter. Now, if we move a little bit down, we could see the oxygen gauge, and then you have the gyro pressure. So in the jet, we use the bleed air from the engines, which creates high pressure, but with that high pressure, we could actually create a vacuum, and that's what this gyro pressure is. And what that does for us is it drives the co-pilot attitude indicator. Okay, back up to the top of the co-pilot side. Here we have kind of our standard six-pack. We have our RVSM capable altimeter, and I did build this little bezel with my 3D printer and put these little bugs inside of it so I could kind of set the decision height. So that's pretty handy. And then this is the attitude indicator that I already said is driven by the vacuum gyro pressure. And here is the airspeed indicator. It's identical to the captain side. And I also built a bezel, and I put these little bugs in there. In the jet, we have a lot of different speeds that we care about. Unfortunately, they only made one speed bug that's built in, and it's this yellow one right here. But we have quite a few more. So how I set it is I set V1, I set to the red one. So let's say V1 is 95 knots. And then V2, I'll set with a yellow one, let's say 105. And then the blue one I'll set to Wiener, which is the maximum rate of climb with one engine. And then the white bug I'll set for the maximum rate of climb with two engines. So moving down a little bit, this is our radio altimeter, and what it does is it sends a beam of radio wave down to the ground and bounce back to the aircraft, and it measures precisely the height that we are above the ground. So if we look at our approach plate, let's say ILS or LPV, and let's say it says 200 feet above the ground is the decision height, we could move this little yellow bug to 200 feet. And what's going to happen is as we come down the ILS or LPV, once that needle reaches the 2 mark, the little DH light will illuminate and we'll get a chime in the cockpit. So moving a little bit to the left, we'll see the co-pilot HSI. More to the left, we go back in time where we have some ADF needles and VOR. So here on the right side, we have a vertical speed indicator. Here in the middle, we have the turn bank coordinator. And traveling back in time, we have the DME. Coming down a little bit lower, here we have some more circuit breakers and some USB charging ports. And here's my air conditioning. And as soon as I turn it to compressor, that's when the AC will actually kick on and give me cold air. And this is the fan speed, which is high and low. So one more quick note about the air conditioning. It is electric, and we can't use it above 18,000 feet because it'll get way too cold for the system itself. But we do have a system in the airplane called the ACM, air cycle machine, which cools down the bleed air from the engines substantially. And that's kind of how we operate and cool down the aircraft above 18,000 feet. So down here is a switch for the ELT to manually activate it from the cockpit. And over here, this right-hand gyro manual mode and slave left-hand, those are what I call dust collecting switches. They haven't been moved in 40 years, but I did actually test them. And what they'll do is if this ever goes out of sync, with the main compass of the airplane and I want to resync it and recalibrate the heading, then I could use these switches right here. So down here I have a manual defog, high and low for the windshield, because these planes have a bad habit of fogging up during approach and landing. So basically 15 minutes before we start our descent, the checklist actually says to put this on low or high. These two knobs here control the windshield bleed air to the windshield. So these are the engine instruments, and I'll cover how a jet engine works in some other video, but this is the fan reading. Basically, think of this as the propeller of the jet engine, and we have these little tapes that move up, these little white tapes. And then this is going to be the digital readout for the fan. Moving along, this is the ITT. Think about this as the heat inside of the engine. Here is the fuel flow gauges for both engines, and this is the turbine. So again, it's a little bit complicated, but it's another set of RPMs that belongs deep inside of the jet engine. So these are the fuel quantity gauges. Also here you can see the tapes. So that's what they look like, and that's what'll appear here on the fuel flow, ITT, and fan. One thing to note is that in a jet, everything is happening in pounds when we talk about fuel. So our fuel flow will be in pounds per hour, and our fuel quantity will be in pounds. Gallons really don't make sense when it comes to jets. And here we have the oil temperature and the oil pressure for both engines, and that pretty much wraps up all the gauges for the engines. So moving down a little bit, we have our annunciator panel. Basically, each one of these lights is labeled, and it's associated with the system on the aircraft. And if they turn on, that means that that system has failed or has been activated. So this here is our altitude selector, and let's say ATC calls and says descend and maintain 6,000. So we'll turn that down to 6,000. And what's going to happen as we pass through 7,000 feet, we'll get a chime in the cockpit, and this light will come on our altimeter, giving us a 1,000-foot warning. So one thing to note is that if ATC calls me and says descend and maintain 5,000, I'll set it to 5,000. And you've been hearing me say 5,000 is set and armed. So what that means is that the light down here has to be armed, or else the autopilot will not capture this altitude. It will give me the 1,000-foot warning chime, but it will not level off at that altitude. Moving down, we'll take a look at the avionics. We have the comms radio. Here I have, on the left side, I have the 530 WAS and a 430 WAS. And on the right side here, I have an Avidyne slaved to the radar in the nose of the airplane that sweeps back and forth and gives me real-time precipitation. And it'll kind of color that on this screen. Okay, and last but not least are my two RVSM capable transponders. Okay, down here is where I control pressurization and temperature inside the cockpit. This is our pressurization selector. It lives on the both setting, which means that both engines' bleed air will be contributing towards the pressurization of the aircraft. Okay, so down here is the temperature controller, and in manual mode, I could just heat up the cabin by holding this up, and then cooling it down is done by the air cycle machine in the back, and I'll explain that in some other video. If we take it out of manual mode, we're actually going to use the automatic temperature control, which has a thermostat, and right about this position is going to be comfortable. This might be a little too cold, and right there you'll just be cooking. This is the cabin fan, and we could turn it on high and low. It just kind of recirculates air around the cabin. And this is our emergency dump. So if we want to depressurize the plane, basically by lifting this cover here and pushing this up, it'll open a big hole somewhere and let all the air out and depressurize the aircraft. So this here looks like a VSI, and it is, but it's a vertical speed indicator for the cabin. So if the cabin is climbing, let's say from 2,000 feet up to 4,000 feet, this will move up. I can actually control the rate with this knob right here. Ideally, we want this not to climb or descend anything more than 500 feet because that's very comfortable and we don't really feel it in our ears. This here is the controller for how I set my cruise. I'll cover this in some other video, but the most important one is this one right here, which will show us how our pressurization is working. So there's actually two needles here, one long one, one short one. The long one is going to point to the outside dial. So if it's pointing here to the 5, that means the cabin is at 5,000 feet. The short one is going to point to those small numbers here, and that gives us a delta. So for example, if we're flying at 40,000 feet, the inside of the cabin will usually be right around 8,000. So the long needle is going to show 8, and the small needle will show the differential in delta, and it's going to say 8 psi delta. But when I fly to Seattle, for example, we usually fly at flight level 210 or 230. What you'll see is actually the long needle will actually stay at 0, and the delta will be at 8.1 or 8.2. So we get maximum differential, but our cabin actually never left sea level, and this will never move throughout the flight. So we actually never feel anything in our ears. So this here is our flap lever, and the way that it works is that you actually have to push it down to get out of the takeoff and approach position. So let's say we just took off, and you'll hear me say V2 plus 10 flaps up. I'll actually push this down and move it up. And what you'll notice is that this tab represents what's actually happening mechanically to the flap. So it'll move up. So I'll say flaps up and indicating. So let's take a look at the throttles real quick. They have two positions really. They're in the off position now. And to get them out of the off position, which means no fuel, that's how we kill the engines, is we just have to push this lever towards the back and lift it. And now, no matter how low you go, you can't actually get down to the off position. So you can push down as hard as you want, and it won't go to the off position. Now let's go ahead and talk about the thrust reversers for a little bit. These are called piggyback style. And to activate the thrust reversers, all you have to do is push them up. And right now, I can't push them up anymore because they actually need to be fully deployed, and there's going to be a little internal pin mechanism in there that says, okay, they've been deployed, and now I can actually push them back even more and actually apply thrust and power to the thrust reversers. So when I pull them up, now I'm saying I want the buckets, the thrust reversers, to open up. And what's going to happen is that's when we look up here, is that the arm light will turn on when the hydraulic pressure is reaching the thrust reversers to actually activate them because they're driven by hydraulic pressure. Then unlock means that they have left their closed position. And then deploy means that they have reached their fully deployed position where they could actually have power applied to them. So we'll have the arm light, unlock, and deploy. So when you think about it, when the deployed light is on, they're also getting pressure, so the arm light will be on. When they're deployed, also will have the unlocked light on because they're obviously out of their unlocked position. So basically we get a light, and then 3 lights. So let's think about this strange condition where, let's say I open up the buckets, the thrust reversers, and I want to close them. Or let's say they open by themselves in flight and something's wrong and I can't close them. I can't push down. Something happened to the mechanism in here. Who knows? And that's why I have this EMER button here. When I push this to EMER, it says override all systems, start pushing hydraulic fluid back to the thrust reversers to direct them to close. And you'll see me using this test before every single flight. I'll open up a bucket and then I'll say, does my EMER work? And then the deploy light will turn off, the unlock light will turn off, and I'll only be left with the arm light, which again means there is hydraulic pressure in the system, but they will stow just with that, even with these in the open position.
Thrust reversers, right side. That passed.
While we're up here for a second, let's take a look at these. These will detect a fire in the engine and they'll illuminate. And if I have a fire detected, then I can open it and I can press this button, and then that will kill the engine and a bunch of systems associated with it, like hydraulic, the generator will kick offline. And then after I press it, it will illuminate these, which means I could start applying that halon into the engines. Moving down a little bit more, here we have our engine sync. And we know what, for those who fly like a multi-engine piston plane, we know that if the engines are rotating at slightly different RPM, there's like a phasing issue that happens and we get this whoa, whoa. And this is the automatic sync. So down here on the left side, this is a guarded switch. It's for the speed brakes. And as soon as I touch down, this is how I extend the speed brakes. I just press it down and then deploy. There is an internal switch at the 85% N2 mark of both throttles that will say once it hits that switch, the speed brakes will retract. So I test it. So before I take off, at some point, I'll extend them. I'll visually see that they have extended. I'll look here at the annunciator panel and I'll see this white light speed brake extended. And then I'll choose one of these two and I'll just move it momentarily past that 85% switch. and I'll notice that the speed brakes have retracted.
Speed brakes. I'll test it with the right.
Jet engines are very lazy inherently, so doing something like this momentarily, you really don't feel it or you don't hear anything. There's just such a huge delay. You'd have to leave it open for a few seconds to actually spool up the engines. Okay, moving down a little bit more. This is my autopilot modes, but I could be like in heading mode, I could be in nav mode, approach mode, I could be altitude set and arm, altitude hold, vertical speed, indicated speed hold. This is my heading bug needle, and this is my course selector, and I'll show you guys this in a little bit as well. Okay, moving down a little bit more, this is how I turn on the autopilot, so I could just press autopilot and that engages it. This is my pitch mode so if I want to raise the nose, I could just turn this down. If I want to lower the nose, I could move this up. And then down here, this is the trim for the ailerons, and this is the trim for the rudder. And last but not least is my elevator trim. I got the wheel here and the indicator. And of course I could, I'll cover that in a little bit, I could change it in the yoke itself and use the electrical servo that's attached to it. Okay, we're finally at the captain side of things. Here on the right side we have the RVSM altimeter, just like the Copilot. We have a big gimbal that is the attitude indicator, and it also has a built-in flight director to it. And here we have another radar altimeter or radio altimeter where I could set a decision altitude. And on the left side is another airspeed indicator with bezels that I built and the bugs for the different speeds that I need. Here on the right side is another vertical speed indicator, and this is my HSI. And here is a standby attitude indicator. Okay, let's talk a little bit about the HSI here on the captain side. So like I said before, I have this little knob here which will move the heading bug. So I'm gonna turn the knob with my right hand and you'll see the heading bug. So let's turn it to a heading of 030, and let's say ATC says turn right heading 120. I can move that. And also with the course selector down there where the heading knob is, I could turn the CDI needle. If I put this into GPS mode, then this will be slaved into my GPS flight plan and it will turn automatically as I reach certain waypoints. Down here is another DME, and here I have the terrain warning system, and I could test that before every flight. And this is an indication that the battery inside of this thing is healthy and charged. And down here I have another altimeter. This one's not RVSM capable, but it's just another great backup. This here is my master warning. The Copilot has it as well. And basically what happens is if any of these annunciator lights turn on, there's certain ones that when the lights turn on, it means some system has failed. And there's certain ones that if they turn on and a system has failed, it'll trigger this master warning to start blinking. And the way that I reset it is if I push it, I'll get it to stop blinking. That means I acknowledged it and it's time to pull out the emergency checklist and follow the procedures. So moving down, this is my landing gear indication. When you see me put the gear down, I'll call 3 green, no red. Moving here, this is another dust collecting switch. It always stays in the on position. It's ABS. This here is very interesting. This is my horn silence. Let's say I'm descending through 20,000 feet and I want to descend pretty quickly at 2,000 or 3,000 feet per minute. I'll want idle power. There's a little switch in here that I'll trigger. And once I trigger it, if the landing gear is still up, it'll say, hey, are you trying to land with your gear up? And I'll have this very loud, obnoxious horn in the cockpit. And you could hear that in some of my videos. Now, what you won't see in the videos is me silencing it with this button. You'll never see my fingers reach over here. That's because on the right side throttle, I do have a switch right here. So what you'll see me is just press it with my pinky here to silence the horn. So speaking of the throttles, I did forget one switch. It's the go around button. Before every takeoff, we do want to press it. And it'll bring up the flight director to 8 degrees pitch up. So what's magical about this 8 degrees pitch up is that it is roughly the perfect-ish angle that the plane will climb really well at with one engine in op. So if we lose an engine at rotation, we'll pitch the plane up right to this recommendation of the flight director. Moving along, we have our landing lights here. Next one is the beacon. Then we have the passenger safety. Ooh, I gotta turn on the master for this because this is my favorite thing. I've owned this plane for 2 years and I still don't get tired of this sound. I love that. My Avionics guys come in to fix this knob here, but these will adjust the brightness level of the instrument panel lights. This is how I turn on all of them. And this is the floodlights here. And it's all coming from up here. So up here on the top left corner, we have our digital clock. This is where I'll keep track of the flight time and things like that. This is the angle of attack gauge, the AOA gauge. And this is the outside air temperature in Fahrenheit and Celsius. So moving down here, we do have the ammeters for both engines. This is a right engine ammeter from the generator, and this is a left generator ammeter. And one thing that you'll see me doing is after we start the engine, I'll test them. So let's say we started the engines and all my electrical components are eating up a total of 100 amps. So I'll have 50 amps on the left and 50 amps on the right. And what I'll do is I'll turn off the left generator, which will move this needle to 0, and this needle will move up to 100. So you'll hear me saying, picking up the load, and then I'll turn it back on, and this will move up to 50, and this will move from 100 down to 50, and I'll say the term sharing the load. This knob here is a way that I can actually select to see, hey, how much is my left generator putting out right now in voltage? So down here is my Avionics master, and that'll basically turn on, you know, the Avidyne, the comms, and the Garmin's. And here's my inverters. I have 2 of them. And basically, if one fails, I could just go to the other one. That's it. And I just kind of rotate. One flight, I'll use inverter number 1. And the next flight, I'll use inverter number 2. The inverter power is different because it powers my attitude indicator. It powers the autopilot. And it also powers the radar in the nose of the airplane. And those are all powered by this 115 volt system, as opposed to the regular power, which is the 24 volt battery or 28 volt generators. So these are my generator buttons. They pretty much live in the on position because I do want them online at all times. The only reason you'd have them in off under normal conditions is if you're getting like a GPU start. This is the master switch, the battery switch, and I basically have to pull it towards me and then up. And you'll see me when I get my clearance on the ground before I start my engines, I'll be in EMER mode, which basically just powers my comms and my 530. So I could get my clearance without using a lot of battery and save that battery power for the engine start. So this is my rotary test switch. This is a switch that will internally test some of the critical components of the Citation. I think it'll be beneficial to actually go through it right now. So we're gonna turn it to the right. So fire warning, and we'll just move up here. And we'll see that the light bulbs are not burnt out. The next one is the landing gear test. And we'll hear the horn, it will be loud. I just silenced it with that button. And another thing that it tests is to make sure that the bulbs are all working. I got 3 green and a red. The next one is battery temp. I actually don't need it in this plane because I have an upgraded battery, so that's in-op. Then there's a spare. Then there's a thrust reverser. And the thrust reversers to make sure that all the lights are working. All 6 of them. And it is cancelable. Okay, the next one is windshield over temp. And basically I'll turn on the windshield anti-ice. And I want to make sure that the annunciator light will turn on. I'm not sure if you guys could see it, but that tests the overheat element. Next one is my overspeed. I want to be able to hear that. And then annunciators. And that is non-cancelable. I cannot cancel it. And then basically all the annunciator lights to make sure the bulbs are working. Right here is a spare, so I really don't mind it not working. And I do keep a lot of extra light bulbs in different compartments here in the cockpit. So these are my igniters. This is ignition switches. Let me explain it this way. You have your propane barbecue at home, right? You turn on the propane and then you press a little button that creates the electrical spark. Then once the flame started, then you could release the button and the flame is just ongoing. That's kind of how a jet engine works. But for takeoffs and landing, we don't want the possibility of a flame out. So we actually turn on the igniters for takeoff and landing and leave them on. Just in case there's a flame out, it'll instantly restart the flame. The next three buttons here are the left start button, the right start button, and the starter disengage. You guys don't usually see me pressing them because the yoke is in the way, but when it's time to start the left engine, for example, I'll press the start button, which will turn the generator into a starter, and it'll start spinning up the engine and run through the whole start sequence. If at any point I want to abort the start, I could press the start disengage. So down here is my fuel boost pump switches. They live in this normal position. I like to call it auto. So if they're sensing low fuel pressure, they'll automatically kick on the boost pumps. But normally they're off during flight because the fuel's getting to the engines by the engine-driven pumps. So this here is my surface de-ice switch. It should really be called boots because that's what it does. When I turn it on, what's going to happen is that the left horizontal stabilizer boot and the vertical stabilizer boot is going to get air pressure. When it senses air pressure, the surface de-ice light will be white and it will turn on. So that's actually one of the few indications on the annunciator panel that means, hey, a light turn on, everything working good. Then after 6 seconds, the light will turn off because they'll stop getting pressure. And then the light will turn back on immediately after that when the right horizontal stabilizer and the wings will get pressure. Next up is the engine anti-ice, and let's take a look at some airplanes that are around here. When you see the leading edge of that jet engine, that is very susceptible to icing. So basically when I turn it on, what's happening is some of the bleed air, some of the hot air from the engine is being directed to the leading edge of the engine nacelle and is heating it up. Apart from that, it'll also turn on some heating elements in the wing, but I'll do some other video about that later. This is the windshield bleed air. So I could direct some of the hot bleed air from the engine to go to the outside in some ports there and blast it onto my windshield. I also have to make sure that I open up these knobs. So now if that system fails for whatever reason and I can't de-ice my windshield, I do have a backup and I could spray alcohol onto the windshield. And I have tested this once and it definitely works. Next button here is my pitot-static heat. In this airplane, the procedure is to always have this on. This will be on from takeoff to landing. It has a 2-minute limitation on the ground. So as soon as I get cleared for takeoff, it gets turned on. And as soon as I land and exit the runway, I turn it off. When it's off, we will have a light in the annunciator panel saying that it's off. And we'll see that anytime I'm taxiing, you'll see the PS heater off. This here is my wing inspection light. There's a little light on the fuselage on the left side that's pointing at the left wing. And that way I'll be able to see at night if any icing is accumulating on the left wing there. So the next one is the nav light, anti-collision light, and then recogs. Recogs are at the very tips of both wings. These here are my left-hand gyro slaves. Again, just like in the Copilot side, if the HSI goes out of sync with the compass, I could use these buttons here to readjust it, but they just collect dust. I've never had to use them. This is my fuel transfer. That means if I want both engines to suck fuel out of the left wing or to suck fuel out of the right wing. Moving down even further, this red handle right there, that's how I could emergency extend the landing gear in case the hydraulic system fails. This is a lock for the yokes, kind of like a gust lock. It's built in. And this is my parking brake. This here is the left-hand circuit breaker panel. Here I have my iPad, and a lot of you guys mentioned that you don't see me using checklists. I certainly do. If you see me looking out the left window a lot, that's not because something's interesting over there. It's because I'm actually looking at the iPad. The next thing to look at here is just like the right side, I have the mic selector, and then I could plug in my oxygen mask in here. It'll get plugged in for every flight. This is a cool button. If I actually push this up, it'll manually drop the oxygen masks for all the passengers. So that happens automatically at 12,500 feet of cabin pressure. But if I want to drop them for whatever reason at any altitude, I can just pop that switch right up. Hey guys, thanks for watching. I hope I bored some of you to death. If you have any questions, just leave them down in the comments and I try to proactively respond to those. And I hope to see you guys on the next flight.